Okay, hello everyone. I welcomes to all in our lecture series on laser physics. In this lecture series, we are going to discuss these topics in detail with note. These topics are very much essential for your B.sc, B.Tech, M.sc, M.Tech and various entrance examinations. In our today's class, we are going to discuss our first topic, that is your basic properties or characteristics of laser and concept or principle of laser. Okay, so let us start. So here laser stands for light amplification by stimulated emission of radiation. So this is the amplification, means we have to amplify or increase by stimulated emission of radiation. What is the meaning of the stimulated, that we are going to discuss in this lecture series, in this class itself. Okay, here laser is a device or optical amplifier produces highly directional monochromatic and coherent beam. So any laser source can produce highly directional and monochromatic, mostly monochromatic coherent beam, and it has many applications that we are going to discuss in our separate video. Now we are going to discuss what is the basic properties or characteristics of laser. Here monochromatic, high degree of coherent, unidirectional, high intense. These are the basic properties or characteristics of laser. What is the meaning of monochromatic? Means almost a single wavelength. So here you can see this light having single wavelength, means one color, only one color, and here many colors, but single laser source if I am going to consider, it has single color. Okay, so any laser source we are going to consider, it will produce almost single wavelength, monochromatic. Okay, high degree of coherent means all the emitted photons have a constant phase. Whatever the photon will be emitted from the source, all have a constant phase. Unidirectional, a high, a very tight beam which is highly concentrated, or you can say least diverge. Here you can see this is your white light, it is spreading all the way in all the direction, but in case of laser you can see it is almost unidirectional, or you can say here you can least diverge. It could not be diverge in all the way, but it is concentrated, or you can say highly concentrated in a single direction, right? Or the so-called least diverge. This is another characteristics or property. High intense, high intense, here you can say high intensity. So mathematically we can say intensity means here power per unit area. P is the power of source per unit area. It will define the intensity of a light. So here I written intensity of light is defined as the energy passing normally per unit area per second through a point normal to the direction of flow, or its value is your this one, power per unit area. Okay, here energy per unit time is nothing but power per unit area is this much. So with an example, if I am going to consider over here 1 watt laser, the intensity will be how much? Here this much, 3.3 10 to the 11 watt per meter square. In case of laser beam, the energy is concentrated in a very small region. Here all the energy concentrated in the small region, but in case of our general light, it is spreaded all the direction. That is the basic difference. 1 watt small region, 1 watt laser source is many times more intense than ordinary 100-watt source, because in case of ordinary light, this source you just consider, light spreads all the way. So per unit area the light passes, for this ordinary case it will less as compared with this laser source. Here you can see this much area, we can say all the light passed through, but in case of ordinary light, whatever the light emitted from this ordinary light, it is diverged or propagated in all the way. So in this, if I am going to consider same area, here same area, less in the same area, less energy will be propagated, or we can say this ordinary light has less intense as compared with the laser. Okay. Okay. Now we are going to move towards basic concept or principle of laser. Here, any laser action from any laser source occurs by four processes, that are stimulated absorption, spontaneous emission, stimulated emission, and population inversion. One by one we are going to discuss detail. Okay. So here you can see, suppose we have two level system. This is the ground state or lower level, and this is your upper level or excited state. At initial stage, suppose we are going to consider all the atoms or molecules or electron are in the ground state or lower level. If we are going to provide energy from outside, then the atom or molecule or electron will be excited to the excited level like this. Okay, this is called as your stimulated absorption. Okay, and after approximately 10 to the power 8 second, automatically here after 10 to the power minus 8 second, automatically naturally it will be transit to the lower state like this. After 10 to the minus 8 second, it will transit to lower state automatically naturally, and it will emit the photon having the energy difference excited state and lower state, that is your E2 minus E1 equal to h mu, or how much energy this atom or electron or molecule taken from the lower state to excited state, that much energy it will be emit at that time of transition. This process is called as your spontaneous emission. Remember it is a natural process, right? Same thing I have been written about the stimulated absorption in your note. Here you can see, when atom or molecule or electron at lower energy level absorb energy exactly same with the energy difference between the two states, then it will excited to higher energy level. This process is called stimulated absorption. So here, when external energy will be applied to the lower energy state, if that energy is exactly equal to the difference of the two energy state, that is your E2 minus E1 equal to h mu, and same energy is incidence on the lower or ground state, it will be excited. That is called as your stimulated absorption. Same thing I have been written. And this process, see, from the outside whatever the energy we are going to provide, that is called as your pumping. And this pumping can be done by various methods, that can be optical pumping, electrical pumping, and chemical pumping. Okay, various pumping used in various laser sources. Here what I written, the excited atom or molecule or electron transit from level 2 to 1 after 10 to the power minus 8 second by emission of a photon exactly same with the energy difference between the two states, whatever I discussed. That means h mu energy gained excited to E2, and when it will transit to E1, exactly same h mu energy photon it will be emitted. This process is called as your spontaneous emission, and this process is completely natural and random itself, not systematic, natural and random. So this is all about your stimulated absorption and spontaneous emission. Often you can get 1 mark upon this stimulated and spontaneous. I am telling about B.sc honor students. Okay. Now we are going to go for the stimulated emission, which is required for your laser action, and it's an artificial process. See, this is your spontaneous emission is a natural, but stimulated emission is an artificial process. How we are going to do that? See, here suppose this atom or molecule or electron is in excited state like this. Okay, if I am going to apply energy from the outside, exactly this much energy, how much energy that atom, electron or molecule taken and excited, that much energy I have been applied over here in this particular stage or state. That means this energy only interacted with this excited atom, only interacted, or you can say it is stimulating this excited atom. Okay, so now it is stimulated the excited atom and then transit to lower state by emitting the photon having the energy h mu. So here h mu energy I incidented and it is activated or stimulated the atom which is in the excited state, and this atom transit to the lower state by emitting the same energy. Here you can see both the electrons have the same energy, and when they are going to add up, then total intensity will be 2 h mu, right? That means here intensity is increased. Okay, same thing I have been written, or we can say amplified, intensity increased or amplified. Same thing I have been written in your note here. When an incoming photon having energy same with the difference between the two states, that is your h mu, outside photon having the h mu interacted with excited atom, interacted with atom or molecular electron in upper level, then it will be triggered or stimulated or forced to transit to lower level by emitting energy h mu. This process is called as stimulated emission. By this process, what is going to happen? Consider suppose one atom, we get two unidirectional photons with coherence characteristics. So after this process, two unidirectional photon we can get with coherence characteristics, means the phase, both the phase has same, due to which we can get a double amplified intensity. So initially it was one, and after transit another photon we get with the same phase. That means intensity amplified or doubled or increased. This amplified light is so called your laser. The intensity will be increased if greater number of atoms will be at upper energy level. Here we discussed by considering one atom on the upper state, and we got the two photons. When this will be uh, de-excite, or it will come to ground state, when the outside photon will be interact, we get the two photons. But you just imagine more than one atom are on the excited state, then what is going to happen? I'm going to show you here. See, here you have to remember, it is important, at the time of interaction, incoming photon do not lose any energy, only stimulate. So incoming photon, whatever is going to interact to the excited atom, this incoming photon not going to lose energy, only it will stimulate the upper atom. Okay, this is the most important point for stimulated emission. Now we are going to consider another situation, this one, in which we have n2 greater than n1. That means population density or number of atoms or molecules in upper energy level is larger than the lower energy level, this situation. So in this situation, if we are going to imagine, that means if large number of atoms will be at higher energy level, then large numbers of incoming photons can be interacted with them, and we can get controlled and high intense laser action. How? This is the situation. Now, three photons interacted with three atoms, and the excited atoms are stimulated like this and transit to lower energy level by emitting photons having same energy or same wavelength. That means we used three photons. After stimulating another three photons, we got with the same frequency and same phase itself. That means we got high amplified or high intense laser action. How we got this one? This laser action only possible if we have this situation, population inversion situation. That means greater number of density in the excited state, higher energy level as compared to lower energy level. Same thing I have been written in your note. Hence, to maintain the appropriate laser action, always we need greater population density of atoms in higher energy state as compared with the lower energy state, which is called population inversion. So here we concluded that to find a high amplified and continuous laser action, we need population inversion. So population inversion is a necessary condition for a laser action of any laser source. Okay. At the meanwhile, we cannot ignore the transition due to spontaneous emission, which is natural and random itself. So after 10 to the power minus 8 second, so with 10 to the power minus 8 second, lifetime of upper level is difficult to achieve population inversion. So here what I am trying to say that after 10 to the power 8 second, spontaneous emission also will be happen. We could not ignore the spontaneous emission, which is the natural. So with 10 to the power minus 8 second lifetime of the upper level, how we are going to achieve the population inversion, which is the necessary condition to finding the laser? How to achieve the population inversion? This is the question will come in our mind. That can be achieved. Population inversion, which is the necessary condition, can be achieved by considering a metastable state, or we can say artificial energy state we are going to introduce inside the material in between these two levels, like this. Then we can get the population inversion. How? That we are going to discuss in our next class. Thank you so much for watching this video. Thank you.